For my science experiment, I tested what the circumference of balloons would be based off of different temperatures. So one temperature would be 35 degrees chilled in the fridge, and the other temperature would be 71 degrees at room temperature. My hypothesis and question statement would be, what is the effect of temperature on circumference of balloons? My outcome statement would be that the colder the temperature is, the smaller the circumference of the balloon. So, for the concept that we need to know for this experiment is that what matter is, because the matter inside a balloon is gas, it's air. Gas is any matter that is gaseous or vapor. Matter is anything that occupies space, so obviously this occupies some space, the balloon as a solid, and then the gas inside the balloon occupies space as the gas. The heat energy is transfer of energy from high temperature to low temperature body. You need to know heat energy transfer because during heat energy, the colder that the temperature is, the molecules condense together and they don't move as fast, where the hotter the temperature is, the molecules spread out more and they move more rapid. You need to know temperature, which is the measure of hotness or coldness of something. And the circumference is the distance around the circle. Foundational skills needed are students will need to be able to find the circumference. You'll need to measure temperature. You'll need to understand states of matter, and you'll need to understand heat energy as well. So my variables, where the measurable variables are inflated balloons. So we have 10 at room temperature, and we have 10 that were chilled, and then the responding variable is the circumference of the balloon. So the responding variable is what responds to the manipulated variable. And then my constants were room temperature, because that was kept the same, the fridge temperature was kept the same, and the type of balloon that was used, those were all the same. And my materials that I needed were balloons, my tape measurer, I used a balloon pump to blow up the balloons, the fridge that was at 35 degrees, and room temperature that was kept at 71 degrees. So my procedures. I gathered all of my supplies. I blew up all my 20 balloons using the air pump. I pumped them 20 times. I used the air pump 20 times each for each balloon. I put 10 balloons in the fridge, and I left 10 balloons in my living room. And then after 30 minutes, I took the balloons first out of the fridge one by one, and I measured the circumference around those balloons, and I recorded those results immediately. And then I took all the balloons that were in my living room, and I measured the circumference of those balloons, and I recorded those results as well. After recording all of my circumferences, I analyzed the data, I made the graph, I calculated the mean, the median, the mode, what the range was. And then for my data, so if you look at room temperature data, the range is from 26 inches to 24 inches to 26 inches. And then if you look at cool, you can see that the data shows the range is from 23 inches to 24 and a half inches. Just 24 inches, sorry, my bad, just 24 inches. And then the average for room temperature was 25.15 inches, and the average for the cool was 23.15 inches. So the data shows that the room temperature balloon circumference was greater than the cool temperature balloon circumference. So also for my room temperature, the median was 25 inches, the mode was 25 inches, and the range was 24 and a half inches to 26 inches. And then the chilled, the median, and the mode were again both 23 inches. And then the range was 22 inches to 24 inches, again showing that the room temperature balloons are greater in circumference than the chilled balloons. And then here's my graph, again showing These are the room temp balloons, and then the chill balloons. You can see that the room temp bar graph is higher than the chill balloons, again showing that the circumference of the room temperature balloons is greater than the chill balloons. So for my results, the average circumference of a balloon left at room temperature is 25.15 inches. The average circumference of a chill balloon is 23.15 inches. And then the average circumference of a balloon at room temperature is larger than the average circumference of a balloon that was chilled. In conclusion, it was founded that the average circumference of a room temperature balloon is larger than the average circumference of a cold balloon. And that is due to the heat energies, because like I said previously, with heat energy transfer, the colder the temperature is, the more condensed those molecules get, because they're moving at a slower rate. Whereas the warmer the temperature is, the more the molecules are spread out and they're moving at a more rapid rate. So with the molecules being more condensed in the chilled balloon, it's causing the balloon to almost deflate a little bit and become more compact, which means the balloon loses its shape and the diameter becomes smaller, those molecules being condensed. For our real world application, the people that would most likely need to know this are party planners and people that make balloon animals. Like, for example, if you were at a skating rink and you were planning a party, you would want to blow your balloons up more so your balloons don't become deflated and lose their shape and they look good throughout the whole party. Or if you were making balloon animals and it was cold outside, you would want to blow your balloon animals up a little bit more so your balloon animal is able to keep its shape and not deflate over time of being outside in the cold. How I came about doing this experiment was I picked a topic, I emailed our professor to see if it was okay. I made a list of supplies just in case that he didn't approve it, which then the next day he did approve. So I took that list of supplies, I went to the store, I bought some balloons, I had to buy a tape measure, and then I gathered everything that I needed, my fridge, my living room, my balloons, my tape measure, my air pump, and I conducted my experiment. And then I analyzed all the data of the experiment, and that brought us here. And again, in conclusion, a room temperature balloon circumference will be larger than a chilled balloon circumference. Thank you.